we'll get started, and the first part that I'll get started with is actually nothing to do with this class, I hope. But I got requested to announce it or discuss it with you in my role as undergrad chair. And I gather that there's been a little bit of, at least a minor issue with plagiarism happening in 4L as a consequence of someone posting their lab on a Facebook page and it getting used. So I just want to emphasize, first of all, it is actually an offense, an academic integrity offense, to be copied from as well as to copy. So when you make your material available electronically, whether it's by emailing it to a friend or putting it on a Facebook page or sharing it, like even the hard copy with somebody, you're opening yourself up to an academic offense. And it's really easy to do it to your nice classmates who you like when it's on a Facebook page, but then you have no control over where it goes and what people do with it. So maybe you share it with a friend who you trust not to copy it and get you in trouble, but when it gets out there, it's dangerous because you no longer know that it's going to one individual who you trust. So Fran actually asked me to talk to you about it. Her initial response was that Facebook pages should be shut down, which is impossible to do, and I think actually not healthy for classes. But I just wanted to remind you that you need to be very, very careful about what you post and what you make available for other people. Any questions?
Nothing good, but like, isn't your lab like your intellectual property then? So then, it's not. How would you get charged for plagiarism if somebody else copied you?
Because you made it available to them, and in fact,
already yours.
Well, but how do you prove that? So if
like,
you
yeah.
no, if you look at
I wrote it and then like.
If you look at the wording in the academic integrity policy, it's both sides are an offense. So if someone copies your work, the part of the reasoning I think is because it's very difficult to prove if two identical pieces come in, who the originator of the work was.
Sure, but if it's like a time delay, like the same idea getting
yeah,
labs from an older
typically,
year kind of thing, no?
Typically people will not charge the originator because they perceive that yours was first and somebody else copied, but you're opening yourself up. Like it really truly is against the policy to be copied from as well as to do the copying. So if you go by the Senate wording in the academic integrity policy, both sides are an offense, and you don't want to open yourself up to that possibility. So please don't post things like that. Please don't make them available. Even if you're not the one who's doing the copying, even if you're the one who did the original work. I actually did have, on a slightly less serious note, I did have a friend in undergrad who wrote incredibly good labs that everybody coveted. And so what he did was he wrote copyright, his name on the bottom, and would only, I mean this was before it was so easy to pass them on electronically. Still could have, but he didn't. But he, on his hard copy, he would only pass it on to someone who agreed to cite his lab in their lab. So
is that kosher? Like, can you cite people's labs?
You could. If you were copying it, I mean, it's the same rules with anything that you cite. If you copy it, you would have to put it in quotation marks, and you'd probably get a terrible mark on your lab because you weren't contributing.
I don't know if I was copying the whole conclusion section or just ideas from the conclusion section.
You could, I mean, I think it would be kosher to cite someone else's lab. It wouldn't be if there was a lot of overlap.
Technically, your friend didn't have to put copyright on it, though.
No, it is assumed.
Anything you make is copyright.
It is assumed.
and has your name on it.
Yeah, but his like personal deal with the people that you'd be allowed to have his lab was that they had to cite it.
You should bring back a strap. You spend like 2 months strapping people who are coffee shit, so no one's gonna. Yeah, yeah.
Well, I tell you what.
Right there in the like the cinch, put that in like a small pot of milk, and then you act it 1 month, and no one will ever copy you.
I honestly don't think deterrents are the answer though, because the second offense deterrent is pretty serious. You get 0 in the course and a transcript notation, and then your third offense
And
is.
35 straps to the back. Like that's
But your third offense is you get kicked out. So those are pretty serious offenses. So I don't think actually changing offenses is I mean, I know you're kidding, but I don't think it's likely to.
Actually,
So,
you
want that job? Anyway, so I promised I would share that. I think it's probably not an issue generally, but.
What do you think the limitations on sharing are then? Like, because a group in my lab didn't know how to do certain calculations for a lab that I already did. So in front of my TA, they were like asking me like, oh, you know how to do this, can you show me? And so I was like, yeah, I can. And my TA was like, wow, that's awesome, good job. Mention that in your lab report that you did, because I'll give you extra marks for helping other people.
So, and that's where things get really fuzzy, truthfully, is improper collaboration is the term that the academic offense policy uses. Not collaboration, but improper collaboration. So it's up to every instructor to share with the class what is appropriate levels of collaboration, and we all want people to work together, and what are inappropriate levels of collaboration. So as instructors, it's up to us to share what we think are appropriate levels of collaboration for our particular class. But if you ever feel like you're not getting enough information from the instructor, and you want to work together, and you think probably it's okay, it's well worth having a conversation with the instructor what they think appropriate and inappropriate levels of collaboration are, because it may be that you have different views of that, and it gets to the point where you get charged and you want to appeal it and take it to a hearing, and maybe the adjudicator, one of whom is now me this year, I don't get to adjudicate any engineering ones, by the way, because it's a conflict, or sorry, at least any chem-eng ones, but they may or may not agree with you, and it's a hugely stressful thing to go through for a student. So if you're ever in doubt about appropriate levels of collaboration, it's well worth asking the prof and clarifying, especially for the entire class. But yeah, that's a very fuzzy one, and it's, I think, a place where things commonly come up is we all, especially in engineering, you're expected to learn from one another, and it's a good thing generally to learn from one another. But where is the tipping point between learning from one another and not doing the work yourself and getting credit for it? Cool. Any other questions? I haven't yet adjudicated any ones, and I'm gonna sit in my first one in like 3 days, see how it goes. It'll be interesting. We'll see. It'll be very interesting. I think I'll come home in a bad mood every time I do it, but it'll be very interesting. So any other questions or thoughts about that? And I asked it to be taped just so that the whole class would see that. Okay. So
my nomination was drafted is officially on the record.
it is officially on the record. But I mean, like, Brian sharing his notes is an awesome thing. From my notes. Okay, so we'll do, I think probably all we'll have time to do in this class is a couple of examples. And just, I think I won't have them recorded because it's boring to watch people working. But it's problem 10.6 and problem 10.15 from your textbook. I will write them up on the board. And if we start going through how to complete them, we'll turn the video back on so that you can see the solutions. But generally, I'll walk around and make sure everyone's on the right track. But the other thing is, this afternoon's class, or possibly the end of the class, but mostly this afternoon's class, I think will be for review. But I don't have a specific review class plan. So I want you, I mean, what we can do is just go through the textbook and talk about what the different parts are and what kind of questions we can get from the textbook. So that was basically my plan, is flip through the textbook, go, oh look, what kind of question could I ask here? What kind of question could I ask here? But if there are any specific things that you want me to talk about at 5:30, let me know, so think about it and let me know. And I will try. I don't have a lot, I have like an hour prep time between now and then, so I can't promise a ton, but I'll do my best. Yeah.
Could you go over the things that you're most likely to ask on the exam? Like not specifics, but just say areas in which we should focus on.
So I'll do that to some extent. If I do it while I'm just flipping through, I'll say this is likely.
Okay, cool. Yeah, because I know we do a lot of like, not tangents, but like relevant information that isn't calculations. So like, is the midterm, or is the exam going to be mostly just calculations?
Mostly calculations. Yeah. Okay, so I'll write the questions up, and I can probably stop keeping. So the first one says that we've got a continuous filter system. The size of the volume of the continuous culture system is 50,000 liters. Residence time is 2 hours. And what we're going to do is put some kind of continuous sterilizer on the feed stream. Okay? The feed stream that's not sterilized has 10 to the 4 spores per liter. Okay? At 121 degrees Celsius, KB equals 1 minute inverse, and at 140 degrees Celsius, KB equals 61 minutes inverse. We want success 99% of the time for over a 4-week fermentation. Okay, so the question is, in the holding section, what's the residence time? So we've got this, imagine it's a tube that's being continuously kept at either 121 degrees or 140 degrees Celsius, and the medium is flowing through that tube. How much time does the medium have to spend in that tube in order that if you do a 4-week fermentation, 99% of the time that you do a 4-week fermentation, you will have no contamination issues. So I just want to sort of say the sterilization questions are typically not really hard. The difficult part is breaking down the problem so that you know what the number of spores is that you have to sterilize. So that's sort of your key question. What is the number of spores you have to sterilize in most sterilization questions?
Are they all similar setup, like with the sterilizing unit and then?
No, we'll do one more. We'll do one more, but that's a common setup for a sterilization type question.
Of course it
Because
Me too. See how you answer.
So like, if you're gonna
Okay,
change
so-
that, depending.
So let's go through this together maybe. So a lot of people recognize that they can use, 1 minus
How you
I can like.
1 minus.
Are you tickling him?
And not. Right, so that's where a lot of people started. As a lot of people found out, if you're using a computer, you're fine. If you're using a personal calculator, it doesn't work out so well. So this is our 99%.
Email.
Right, so the whole thing ends up as, we can just end up with those two things on either side. Right? I think you guys use more or less this. The place that I think everyone has figured out is which TV you use where, how do you figure out what, I've given you some times in here. A lot of people were inclined to just put that 2 hours in. They saw a time and they just wanted to put the 2 hours in for their tea. But the tea is actually the amount of time it spends at the sterilization temperature. Right? And that's what we're asking for. How much time does it need to spend at the sterilization temperature? And when you have a continuous system, the really hard part is figuring out how many total spores do you need to kill off. Okay, so how many total spores did we need to kill off? How did you figure it out?
Well, I mean, you gotta flow rate.
Right, so you're given a residence time in your reactor and a volume in your reactor. So our flow was 50,000 liters per 2 hours, right? So that's the flow that has to go through the sterilizer. And we know that the thing has to run for 4 weeks. Okay? So we have to do this sterilization for 4 weeks. So we've got 7 days per week and 24 hours per day. Hours. Now we've got how many liters need to be sterilized total. And then we've got 10 to the 4 spores per liter. And that's how we got it on. Okay, everyone's good with that? Okay.
How did you get 4,000?
Okay, so when a bunch of you plugged in your numbers, figured trying to figure out what the PET was, in your calculators you found that it didn't work well. Because your calculator cut stuff off. So that's why you need to use the sterilization chart. In your textbook, and that has 1 minus P there, and it has KT here, and it has a bunch of lines with end knots there. Okay, so what you do is you find the line that matches, you're going to have to use a bit of interpolating, but you find the line that matches your end knot, and there's your 1 minus P is kind of minus 2. So you go like that. Over to there maybe, and then you go down, and you find that I think it was about 30, maybe 33, was your KT. And you're given your different KDs at the different temperatures, you calculate the time out. So that's how you actually go and solve that problem. questions like this, and there will probably be a problem like this on your exam, not exactly, but similar to this, is figuring out which time you use when, how you actually figure out what your end dot is. Yeah.
So the answer to this question would just be the 30 divided by 61?
Yeah, I guess it was 30.33, but yeah, 30, about 30. So 30. So 3 equals 30 over 1 equals 30 minutes. And T1 and T2 equals 30 over 61 equals about half a minute.
Well, here's the question. Practically, when you're setting these up, that means that's 30 or half a minute at 121, 140 degrees. So it's like, say the 30 minutes, that's like a lot. So you would have to get it up to that temperature, let it sit for 30 minutes, so then.
No, so it's continuously flowing through a tube that is continuously kept at that temperature.
But how are you, that's like assuming instantaneously heating from.
So you do that by steam injection.
Yeah, like that's, you're flowing 25,000 liters an hour, that's 462 minutes.
Yeah, so this is actually what we were talking about. Probably the first, I mean, you'd have to do a bit of some temperature sensors on it to know what your amount of space was in your tube that didn't get sterilized properly, like in real life. What you would do is have an injection port, maybe just right there, that is putting in a lot of high temperature steam to get it, so you're actually adding high temperature steam to your medium. So you get very fast heat transfer to your medium because the high temperature steam is actually mixing with your medium, right?
Okay, right.
And that's a big problem, is that it dilutes it. So when you're looking to get it up to 140 degrees Celsius, right, 140, you're gonna have to add very high temperature pressure steam and in higher volumes in order to get it up to that temperature for the sterilization. So when you mix up your medium, you may have to mix it up at a higher concentration in order to allow for the dilution required for that sterilization period. Because it's hard to get that much, because of heat exchange is hard for those sort of volumes. When you're getting 25,000 liters an hour,
But like,
it's hard
rough
to get
calculation,
that.
that's 208 megajoules. Or megawatts, like, no, that's megajoules per minute. So anyways, but like, that's a huge amount.
So it's
Like, is that
expensive.
reasonable?
Sterilization is probably about a third of the cost of running a bioreactor.
You know, if we went to Pennsylvania, there's no escape route places.
Yeah, you absolutely have to pull it down. But it's a lot easier to do, have to pull glycol.
You're just trapped in a
than
room.
like you need to get that. Well,
It's a valid concern.
it is. And I mean, you can make emissions where you could, but when you have a challenging heat exchanger, and you have with the edge being a much higher core of still, right? And you need everything to be well mixed. It's true, but you still have,
Yeah,
you
that's
should
what I
have
want.
power when it's not, because it's not sterile at the start.
Maybe. I want
And
everyone to be able to
it end up basically burning around the edge, and you get to the start.
It's more fun to go with like a smaller group too, like 5 rather than yeah, we can invite people like
So it tends to be the rather than, but it's like
out of our exam, people would invite to things anyway, would be like,
yeah, no, it's sort of make it created Okay, so we'll do the next example next class, and I'll do a very quick run